Alright, so today let's continue with some more assembly. And from last time I just added a few unit tests and I added this Nix like checker bash script, which lets you run the checker if you have a Nix installed. And I also added some flags for the stages of the compiler, so lexer, parser, and assembler. So right now we are generating, if we check the assembler, right, we generate some assembly, but we only generate the functions that we manually create. So let's check the example, right? So we generate just for dot and main, right? And I would like to automatically generate the getters for IVEC2 and also the constructor, because the constructor is also missing. So if we look for the constructor, yeah, it's not in the thing. So let me just see if I have in the history all of this part with example, right? And it's gonna complain that it cannot find this symbol. So we actually have to generate ourselves the getters and the constructors for data structures. So if we go into main and check out the assembler emit, we'll see that here we emit the data structures and here we emit the functions. Functions are kind of done. I'm just want to create a mapping between the function name and what's gonna be in assembly, because right now you can actually put any symbol in the function name. So you can even have functions like I don't know, like this, right? So it would be weird to have that in assembly because it's not gonna work. That's the first thing. But other than that, the assembler for functions is completely done. And the reason why it's done is because it was extremely easy. You just have to, well, after we are gonna add if statements, we have to modify it, but for now it's done. And that's because the body of a function is either a function call or a push of an integer on the stack. So it's just function calls pretty much inside of a function body. So it's really easy. But for the data structures, we are not done. And that's because, yeah, data structures kind of suck because you have to implement a lot of things. We have to implement the constructor and the field getters. So let's go ahead and I mean, I think I should have test ASM, which contains the constructor for the IVEC2, so we can use this one as an example of what was happening, right? And let's go ahead and try to use that information that we gathered last like 2 times ago. Yeah, I guess that's a new expression now. Okay, anyways, so we have the IVEC2 constructor. All right, let's try to get this thing. So even for data structure, I think I want to rename them in assembly though. Yeah, we'll have to see. But first of all, let's do the constructor. So the constructor is gonna be a function, and if we check our let's check the generated assembly. We expect that the name of the constructor is func and then the data structure name, right? So it's exactly what we have here, func and then data structure name. Then we have the classic push, allocate variables, and so on. So let's copy paste this part. Oh, I wanted to have it like, can I? Yeah, nice. I still have so we do all of this, right? And the ending should be also the same. Although we'll see, maybe we want to allocate more variables, right? Because it really depends on how big the data structure is, right? It depends on how many fields it has. But yeah, no, I think this shouldn't be that complicated actually. So here we need to allocate some memory for the, let me put a comment. First step for our data structure constructor is to allocate memory on the heap for the fields, right? And in this case we had two fields, they were integers, but that's not really the important thing. The important thing is that on the heap we allocate pointers, so it was 2 pointers times the size of a pointer is 8, so we need to do 16. So we need a way to figure out how many fields we have on the data structure, and if we check out the data structure we have the fields here, so it shouldn't be unsigned int size, should be data fields count times 8, and I should have a define maybe for I think I called it stack size. Yeah, stack SZ. Let's call it stack SZ8. Or maybe it's gonna be word size. Right, and word is basically a pointer, so stack word. So we also have the stack prefix. So this is the size that we need to allocate. Right. Let me just put everything with emit. Here we need to do a size. I mean, I think if it's unsigned, it has to be du, but I don't know for sure. Anyway, this part can be done. So yeah, we actually have to say that the t0 variable is gonna be the is gonna be allocated on the heap. So we use this stuff, right? So that's the size we need to allocate. Perfect. Then we need to pop each field. All right. So right now, let's do something like this. So on the stack, we have like we imagine that we have all the fields already there, right, on the stack. So if we pop the first field, we initialize it. If we pop the second one, and so on. So yeah, the idea would be to pop each field from the stack. Now it's interesting. In this example, I had to store them in the reverse order, so we'll have to think if you want to switch them around or not. But yeah, and then the second one. So just to see the example, right? So now we have a for loop. For unsigned int I is equal to 0, I should be less than fields dot count, and these things you can see that they look almost the same, right? they look almost the same. So I could do something like stack st data field. It's a field dynamic array get. I mean, this part is not really important. I just want to get the name so I can, you know, create a nice comment. I cannot get rid of this habit. Just kidding. So here it's field. Right, we try to get it. So now we have field.name and also field.type, which is not really important. But what do we need here is this guy. Let me just do the emit. I want to replace this thing with the name. So it's gonna be, but I need to allocate it. So char star a name is gonna be null. ds string slice to owned field.name dot value, and we do it into name. What do you mean? Here it's name, and then we do ds free null name, so we read. Okay, so yeah, that's just for the memes, let's say. I mean, yeah, you cannot really break. Okay, so then we have stack pop, right? We pop from the stack, then we get our first variable, which is gonna be location 0, and here we need to put %d, and we need to do I times stack word size, right? So here we need to put the offset where we want to store the field, and for the first field it's going to be 0, for the second field it's going to be 8, 16, and so on. And these increments will be by 8 because we store pointers, not the actual values of the fields, right? So that's kind of the convention that we thought about, to try to use pointers. Like everything is gonna be basically pointers unless the original int values, which are still on the heap, so they are still pointers, but they are like if you imagine a tree, they are the leaves, right? The last thingy. And then the last thing, let's not forget, is to push our variable on the stack. And again, see, t0, it's the result of allocate, so it's gonna be, I mean, even this one is du, so it's gonna be an address, right? So here you see we push on the stack an address, so that's the point. Okay, so that's how we emit our constructor. Let's see if it works. So we have ivec2. I mean, the u didn't work, but it's weird. I thought you need to put a u. Maybe I'm wrong. I don't remember exactly how you do unsigned, but you can see that our ivec2 constructor is actually, like, it actually exists now. Function ivec2, and it's used somewhere here, and it's like the same thing that we had originally, so hopefully it's gonna work. All right, so this is the constructor, and now we need to create functions for each field. So yeah, this was the constructor, and now let's do a for loop at the end, right, over each field. We need to get the field, so it was a good idea to have this. We still need a function name though. Maybe it's a better idea to rename this thing into field name, just so we are on the same page. All right, so it's still a good idea. Let me just copy paste this entire for loop actually, like, why not? Why the freak not? Okay, so we copy paste all of this, and now we have to do something else in here. So if we go, let's just copy our xgetter, right? Whoa. Let's put it here and let's see step by step what happens. Or, I mean, we kind of know already what happens, but just to get a better idea. So we won't have these comments, they're useless. And actually the function is going to be like this, but that's something we just learned, so that's fine. So first step is to have our function name, which is going to be like this. Again, I might want to rename the fields and the structure. So I might have to do that because, you know, you can have any kind of names, but here is going to be name and field name. And maybe I want to rename this into data name. So it's the data structure name. All right, so we have our label. That's the first step. We need to allocate, like we need this part, right? We need this part to allocate variables and remove variables, obviously, at the end. So we can just remove all of this, which is implemented already. And now it's gonna be interesting, I guess. I think this is the hardest part. We need to allocate. Again, I think we need to allocate only 8 always. I think it's gonna be pointer regardless of the size. I'm not sure though yet, but I think it should be just a pointer to the original thingy. But I'm not sure. Yeah, this is really bad though. Ugh. Like at this point, maybe we need to know some more information about the fields, like based on the type. I don't know if allocating 8 is gonna be enough. So why is that? Why can we not allocate only 8? Well, let's say the field is an integer, then 8 should be enough, right? 8 is a pointer to an int. But what if the field is an IVEC2? We want to copy the entire thing, right? But even then, when we created a data structure, we only put a pointer here, so maybe it's fine. So even the constructor won't work then, probably, I don't know. Right? Because we only allocated this. Well, let's first of all make it work for int, and then we'll see how it's gonna work for other types in the fields. So Yeah, right? Because then even the constructor doesn't really make sense, but who knows, maybe it's gonna be that easy. All right, so we still need to allocate into T0, which is exactly this thing. But funny enough, we only need to allocate stack word size. And I mean, that's what I hope, to be honest. Otherwise, we are gonna be cooked. So, yeah. Okay, let's also copy the push T0 because that's an easy one. And now let's take a look at the ugly part, which I guess memcopy is not even gonna be needed if we can have only 8, but pretty sure it's gonna suck really bad. But we'll see, like maybe it's gonna work only for int, and I'm fine with that for now, right? Let me just put here like a %s and have field name. Right, so here I said pop the IVEC2 from the stack. We get the address of the IVEC2, right? That's the idea. Then we get the field based on offset. So this field, again, here we need some kind of offset plus %d. First field is 0. The second one is gonna be 8, and so on. If I'm not wrong, let me see. So this is the x getter. Yeah, plus 8, right? So here we need some kind of offset. I times stack word sz. Right, so in Rx we have the address of the IVEC, and now we get the offset inside of it. And here we put I mean, at this point we just want to copy into this address the value from Rx. So yeah, like it could be the same. So if it's gonna work only with 8, I could do just, let's say I do this and something like this, and then I just move into, let me just do RDI, we move into RDI like this, we move RSI, right? That this would be the same thing, but let's just leave it with memcopy for now, because I'm really not sure if this is gonna work. Like if it's gonna work for any kind of data structure, because for IVEC2 it's gonna work, right? For sure it's gonna work. So this should be all actually for data structure, believe it or not. But again, I'm not really sure if it's gonna work first try for other things as well. So yeah, we just created everything. So if we run it, oh, we don't have multiplication. So for multiplication, we need to go to our stuff here and just add multiplication as well. So we add mul, right? This is gonna be multiplication. Whoa, what? Multiplication, and it's gonna be called int. I have more, I don't have more. Star, yeah, star. Anyway, we have star. Whatever, that's not important. here we add, I think it's called mul in this assembly. Let me just make extra characters on the line. Oh shit, I think mul works differently. Multiplication in assembly, right? So multiplication fucking sucks, that's what I remember. So we put ax here, cx, and the mul is gonna multiply ax with cx, and it puts something else in dx. So might as well do it like this, right? Multiply rdi, which is gonna multiply rax which is going to multiply rax with rdi, and we are going to have in rax the result. So then I could do something like move rdx rax, right? And if we are unsure, let's go into the assembler, emit multiplication. We did move rdi rax, mul rdi, and that was all. Okay, fair enough. So that should actually work. Nice. Let's see. So make, and we get freaking 69. So somehow all of this entire shit, I mean, we haven't done dot product. So yeah, and what I said is here, this is x and this is y, I'm pretty sure. So if I run this, we should get 27, I think. Yeah, so that's what we need to think about. Do we want the items to be in reverse order when you call the constructor, or do we want the constructor to say this is x and this is y? So that's you know, like, to be, let's say, on the same page with all these math operations, I would say maybe the reverse should be the case, but I don't know. So yeah, so let's do 1 ivec, and then let's call ivec2 dot. Let's see what happens if we do this. Yet we get a 2. I wonder why. Isn't dot product between maybe I made something wrong here, but I don't know for sure. Let's see. I mean, the plus works. This should be like 28. So stuff kind of works. Let's do 1 ivec2, and then let's pop it. I have the pop keyword, so pop should just remove all of that. Still works, that's cool. But okay, let's say I do this one. I get a 1. Let's say I swap and ivec2.y. I should get another 1. Let's say I do a plus, so I add them together, I should get a 2. Nice. Let's say I rotate and I do ivec2.x, so now I should get 27. Nice. So if I dupe and then swap and then ivec2 dot y, I should get the 42. Nice. So if I do now, like, what would happen if I do plus? I think it should be 69. Yeah. If I rotate and do a multiplication, it should be what? Like 27 or something, right? It's 1 for some reason. Okay, let's think about it from the beginning. So here we have 42, 27. Then this thing is converted into the IVEC itself, right? And the same will happen for 1, 1. So at this stage, we do a dupe. So we duplicate this entire thing. Let me just remove that. So we call to X. So here in this thing, we are gonna have a 1. We swap. So we remove this with this. We do a 1. And then we rotate. So if I rotate, this thing should come first. That's the only thing that happens, in fact. If I dupe and then do that, so we dupe it, and I do a X, it should, I mean, I put them the reverse order, but you get the point. This is X. So this should give us 27, and it does. So then I swap. And I do ivec2.y, so this should give us 42. 42, nice. And then if I rotate, this should just take 1 and put it here. So if I pop, if I rotate, it should be 1. If I pop, it should be 42. If I pop again, it should be 27. And again, it should be 1. Nice. If I pop again, what will happen? I don't know. I think it's gonna be a fail. Yeah. So that's good. If I do multiplication, it should be 42. Huh. If I do plus, it should be 43. Okay, so multiplication is wrong in main. Okay. So shit, here it's RDI. I don't know why I put RDX. I'm just a dumb. Okay, so if I do multiplication, it should be 42. Nice. If I do swap, it's gonna do it like this. If I do a rotate, it's gonna put 1 first. If I do another multiplication, we should, so if I do that, it should say 1. Yeah. If I do multiplication, it should say 27. And if I do plus, it should do 69. Yeah. Okay, cool. It means, looks like it kind of works. 69. Right, so even function call works. Okay, that's kind of cool, I'm not gonna lie. But what if, and now comes the important part, what if we have a data complicated, I don't know, and we have IVEC2, this is the IVEC, and it also has an integer n. Like the types and everything like have no meaning. Basically, these are just comments for now. But what if we do that and then we say 69 and then complicated? What if we call complicated dot n? Oh my god, it's gonna be cooked. Shit. So indeed we are cooked. I have to put them. Yeah, I forgot about the reverse order. Am I right? 69. And if I say complicated dot I and then I vec 2 dot x, is it gonna be 27? Oh my god. But why does it work though? I mean, I'm I'm really surprised that it fucking works, dude. Holy shit. I mean, yeah, it just worked. What the fuck? So, but why? That's interesting. I mean, to be honest, I don't even have to ask why. And I mean, let's just be happy that it works, to be honest. For fuck's sake, why does it work? It works, it works. I mean, if it works, it works, you know. What can I say? Yeah, maybe it's a bit confusing that you have to put them in the reverse order. So I have to think about this one. Right, I think I want them to be the order that you say in here, that's the order you put them here. So it's gonna be a bit of a syntactic sugar, but damn, it just worked. That's nice. I guess we just used pointers for everything, so that helped. But I mean, you know, I have to make like a small explanation. Maybe I guess I did a drawing 2 times ago. 2 times ago, bruh. Like not the last time, but the time before that. So I guess when I did that explanation, I had an idea of what will happen better than I do now, I guess, for some reason. So yeah, but yeah, so the idea is, see here we allocate. I mean, I guess I could just redraw stuff, right, just to remember how it was working. Oh, but it was something like, here we have the memory, right, and we split it into 2 pieces. This is gonna be the stack and this is gonna be our heap. So that was the idea. And on when I do allocate, I just reserve some memory here. So 16 bytes, it means 2 words, right? And I put that into a local variable. So I have here a t0 and I say that t0 points to this. Then we have t0.x is equal to pop. So I do a stack pop. Here we also imagine that we have stuff on the stack, right? So I do a stack pop. I get this one and I just copy it here. So this is a pointer. So this is actually going to be also a pointer. So I pop this one and I put it here. And then I pop another one and I put it here. So I pop this one too. This was a pointer. And then I push t0 on the stack. So t0 comes here, which is also a pointer. So t0 was a pointer after all. But is being pushed on the stack. Right. So now if I do xgetter, right, I allocate t0 like a t0 again, right? I allocate another variable here. So I have another t0 now. You can forget about this one. We have another t0 that points here. That's all it does. Then we stack pop. So we remove this thing. We dereference, right? So since we pop it, we get the p. right? That points here. So it's the old t0 if you want to think about it. Then we get the field based on the offset. So because we want x, we say plus 0. So it's p plus 0. So it's here. Then into RDI we just put t0, so our new variable, into RDI. Into RSI we put this thing, and then we call to memcopy, which again I think is not gonna be needed anymore if this thing works. And what memcopy does, it copies into this place to t0 what's here. So it's gonna copy this p. This p comes here, right? And I guess I forgot to draw it, but let's say here it's a 0, here it's a 1, right? This pointer points to a 0 and this pointer points to a 1. So if I do the int getter now on this thing, it's gonna, like, these two are the same value, are equal. This thing is and this thing are equal. So this thing actually points to the 0. So that's why this thing works. And if we do the same thing for an entire IVEC, the entire IVEC is also just a pointer. So yeah, I guess that's why it works. So maybe memcopy is not going to be needed. Let's try that. Let's try to remove the memcopy. So where is memcopy with what I think should be here instead. So let me just copy all of this. Oh, so I put t0 into RDI. So I said that I want to do something like RAX is equal to what's at the address of RAX, and then oh shit, move, what the fuck am I doing? Move a Q word at RDI like that. So I think this should in fact just do the same thing. Right. So you don't even need that then. Complicated let's dupe it, let's swap, let's ivec2.y, and then let's plus. Oh shit, what? So I duped and then I called to ivec2.x. Why didn't it work? 27. If I swap ivec2.x, let me try. Oh shit. I guess it doesn't work after all. Yeah, so maybe we are cooked. Did I maybe forget to do something in here? Like maybe I forgot to replace something. Let's check out how the assembly looks like for that function. So for I, it's like the second field. And maybe I'm wrong somehow. Here we just stack pop. maybe, yeah, I'm actually wrong about how these things are working. And here I just copied. So this thing puts something into RAX, the address for the IVEC2, then I move into RDA plus 8, which is the beginning, plus 8, I move the address of the IVEC2. So it's like this. So let's imagine that this is the IVEC2 and this is the I field of that structure. So I move this pointer here. So it's a pointer that points to this place. So if I do IVEC2, so if I call the I function, I just get this pointer again. But yeah, I might have to dereference it somehow. Yike. Yeah, I guess I was wrong about how easy it was actually. All right, because this thing, it's a pointer to this piece. So it needs to be, let's just say, dereferenced once. So like if I call ivec2.x, I saw that it works fine. But why if I do .y it doesn't work anymore? Not really sure about that. But I mean, I'm gonna say that for now things work. Right, ivec2.x. Like for now things seem to work. ivec2.x. For now things seem to work, right? Somehow, like, don't work really well, but kind of work. So I'd say that this is a good progress for now, and we can try to figure out what's wrong with our memory management in the next one. So for now, I'd say that yeah, let's do again the 69. So this should provide us with the 69. So I'd say that it works decently. We cannot really have nested data structures, so I have to figure out how to fix this. And yeah, we'll try to add more stuff in the next one. So see you. Right, so somehow just by drawing, I kind of found something interesting. So if we go to test.asm, what I noticed is that let's say that I'm doing the case where I want to have the nested data structure, right? So why allocate a new one, right? Why allocate a new IVEC2 when we already have the IVEC2 on the heap? So my idea is, let's not allocate anything new, right? When we do the getter, let's not allocate. We just pop from the stack, so we get the first item from the stack. We dereference it once, and if we dereference it once, we now point to the old memory, right? So when we point to the old memory, what if instead of doing this stuff and this stuff and this stuff and all of this, what if we just do something like this? What if we just push on the stack here the old t0 basically, right? What if we push the old variable on the stack? So if we go now to main, that's exactly what I changed here. What if instead of pushing that, like creating a new variable and stuff like that, what if we just push the old one on the stack? So now we have the vec2.x, and then we just do plus. So let's just make it just to be sure. And now we also get 69, right? Let me also just do something like dup complicated dot n, so we get also the n, and at the end we do another plus, so we should get 69 plus 69 is, did I make a mistake here? I don't know. We get 69. Huh, what? So weird. I thought I'm gonna be able to call because I duped it. Huh. So let's just go step by step, right? So 42 that and 69, we put it inside of complicated. If I call dupe, I just have the same pointer twice. So if I call pop and then complicated, is it gonna work? Yeah. So then if I call complicated dot n again, why doesn't it work though? Because it's the same thing, isn't it? Oh, I'm whoops, I have to swap. I forgot to swap. I get 69, and if I add again, we should get, what is that? 138, right? We get it. So I think that was the problem. Let's not allocate anything new when we call the getter. Let's just use the old one. So we don't allocate anything new. We just use the old allocated memory. And that thing seems to work much better. Right. So maybe I can find more optimizations like this, because you can see how big this was before and how small it is now. Or maybe I can also say here like a comment, maybe it's like we pop, what do we pop? We pop percentage s data name, and then we somehow push the field name, but I don't know how I'm gonna say that in a really cool way, because you can see that we pop the data structure and then we dereference the offset. So maybe I can just say that we push this.